In this video, we are going to talk about t-test. It is used to test two population means. The t-test is a test used with a two-class categorical independent variable and a continuous dependent variable. So you can see this flowchart. Let's first take a look at the dependent variable's level of measurement. It must be a continuous, and the independent variable's level of measurement, it must be a categorical variable, and it must only has two categories. Okay, then we're going to use the t-test, which is we're going to cover three different t-tests in this chapter. So the first example, compared to males, do females spend less time in the prison? The dependent variable will be length of the incarceration measured by the year, or maybe month, but by the year, 1 year, 2 years, 3 years. The independent variable will be the gender, coded as male and female. So as you can see, the dependent variable is a continuous variable. The independent variable is a categorical variable. So the proper test that we are going to test this question, or we are going to explore this question, is going to use a t-test. Differently, if we're using the officer's race and the number of tickets they write, and we use this example in the previous PowerPoints, right? So the dependent variable will be the number of traffic tickets the officer write, and the independent variable will be the officer's race, and it has 1, 2, 3, 4 groups. Okay, so the proper test to explore this research question, since the independent variable has more than 2, like 3, 4, 5, then we are going to use ANOVA, which will be covered in another PowerPoint. So in many situations, one of the things in criminal justice, criminology, and even in most of the social sciences is that we are interested in testing for difference between the two means and the two population means. Okay, the offender sentencing by gender in the previous slide is a good example of that. We are very interested in comparing the two means of the two populations to see if there is a significant between the two populations regarding their means. And because of that, and most likely we don't really have, or we don't really often have, a very large sample, so we usually use the t-distribution. Again, t-distribution is a family of curves that really varies based on the degree of freedom or degree or kind of a sample size, right? It's based on the different sample size. It's very flexible, and it is more safe to use the t-distribution to run the t-test instead of use the other distribution, such as the z-distribution. Okay, so for social sciences, especially when we have not so many cases, less than 100, or sometimes even a few more, we use the t-distribution to run the t-test. Some of the basic concepts in the t-test before we actually go into an example. One is that we are going to distinguish the independent sample and dependent sample. Okay, we talked about the dependent variables, independent variables, but dependent sample and independent sample are completely different from the variables. So independent samples basically means the sentence is too long, but basically means the two samples are somehow not related. Okay, as you can see, the two samples, one must coming from one population, another one must coming from another population, and they are not connected each other. For example, compared to males, do females spend less time in the prison? So we got one sample from the male prisoners and one sample from the female prisoners, and somehow those two population, male prisoners and female prisoners, are not connected. They are not the same person, right? Of course not. And you can't find any connection between two of the populations. So this is what we call the independent sample. Okay, the dependent sample is that we somehow to say that two samples are related by some means. Okay, the most often you will see the dependent sample test is within the pre and the post test. For example, I have a student who has a stats like a whole classroom has average stats like 70 in their midterm. Then I give them a tutor who is really good, and so the tutor actually working with the students to improve their grades. Then in their final they probably have an average of 75. So I wanted to see if the tutor is actually working in improving people's stats grade. Okay, this is like the pre and the post test. And also we will see dependent samples very common in the match pairs. So we will talk about this in our further example in this PowerPoint, later in this PowerPoint. Okay. So when we're going to decide which t-test we are going to use, as I mentioned a little bit in the previously, that we are going to talk about 3 different types of t-test. Okay, so the very first thing is that you have to decide which t-test you are going to use. Okay, and the very first step in deciding which t-test is going to use is to see whether the samples are dependent or independent. If they are dependent, then the dependent sample t-test is going to be used. If they are independent, the independent sample t-test is going to be used. The second step in deciding which t-test is going to use is to check the variances of each samples are equal. Okay, so basically means if they are equal, then the 2 population variances are similar to each other. So we can combine them into the 1 population variances to estimate, which is also called the pooled variances. But usually I say like equal variance, assume equal variances or unequal variances. If they are not equal, which means they are unequal, then they must be mathematically manipulated before combined. So they have to analyze separately. Okay, so the question to whether the variances of each samples are equal or not is another decision you have to make. Actually, it's a second decision you have to make regarding which t-test you are going to use. Now, to be noticed, in the dependent sample t-test, there is no such kind of a consideration regarding whether the variance is equal or not, because they are the 2 samples, the 2 populations are somehow related. They are dependent on each other, right? Another thing in the t-test you have to make, the third step to make your decision is whether it is a 1-tailed test or 2-tailed test. So I mentioned this one in the previous PowerPoints a little bit, right? So the 1-tailed test, also what we call them the directional test, is that means as you can see, we're using the t-test, so using the t-distribution. The t-distribution always have 2 sides, right? Left side, right side, positive side, negative side. So 1-tailed test basically means that we have a direction. Something is larger, something is smaller, something is faster. Okay, we have a direction that we know which way we are going to look at. Maybe it's a positive way, which is larger, bigger, better, or it is maybe a negative way, which is less, smaller, something like that. Okay, now in other side, we also can have the 2-tailed test. Is something we call the non-directional test, because the t-test can go either way, and most likely for some questions that we don't know which direction is correct, or we don't assume which direction is the way. Okay, so for example, like in criminology or criminal justice, you may consider that male inmates may spend more time in prison compared to female inmates, which literally makes a little bit sense, right? But if I'm testing a question like a male inmates reading hour in the prison compared to female inmates reading hour in the prison, you actually don't have a very good theory or assumption to assume maybe male inmates are reading more frequently than the female inmates, or female inmates are more likely to read a book in the prison than the male inmates. At that moment, you don't have any idea about what's happening. You can assume based on the theory or common sense or your personal experience, you can't assume the direction, then you have to use a two-tailed test, which is a non-directional test. That means like it could go to the positive side or it can be the negative side. Okay. So whether decide to use one-tailed, t-tailed that will impact the critical, just like the t-critical, just like the chi-square critical. It is used in the step 3 that we are going to use it to compare to the t obtained, just like chi-square obtained. Okay, and how the hypothesis will be written. So for the one-tailed test, we have touched this a little bit in the previous PowerPoints, is that the null hypothesis will always be the two population means are similar. There is no relationship between gender and the length of incarceration. So male inmates supposed to be having the same time as a female inmates when they are in prison. Okay, so the mu one, the mean of the population one, equals to the mean of the population two. Okay, the alternative hypothesis, since it is directional, then we assume some direction. For example, the population mean one, mu one is larger than the population mu two, or on the opposite side, the population mu one is less than the population mu two. That's a directional test, right? See, larger, smaller, we make a directional guess. So for the two-tailed test, again, the null hypothesis is not going to change. They are going to be equal. However, the alternative hypothesis will be a little bit different because we don't know if it's larger or smaller. So we can only, or we can simply say it's unequal, right? It's a way that when we can see the direction, when we can't assume the direction. So whether decide to use a one-tailed, two-tailed also depends on like how you ask your research question. We use this example in the previous slides, previous PowerPoints already, right? Compared to males, do females spend less time in the prison? Did you see the less time? So yes, it is a one-tailed test because there is a less time, right? There is a direction. So the second question is there a difference between male prisoners and female prisoners regarding their prison time? Now, you can see the two questions are sort of similar, right? It both ask the question about the time male spend in the prison compared to the time female spend in the prison. However, this research question, is there a difference between male prisoners and female prisoners regarding their prison time, has not telling you bigger or smaller, more time or less time. Therefore, we don't assume the direction. Maybe the male prisoners spend more time, maybe the female prisoners spend more time. So it is a real two-tailed test. It can go either way. Okay. So there are the summary. This is a summary about the steps for deciding among 3 t-tests which one you are going to use. First of all, ask a question to yourself: are the samples independent? If the samples are independent, are the variances among those two populations are equal? If it's no, then we're going to use a dependent sample t-test, because if the samples are not independent, that means they are dependent, right? So we use a dependent sample t-test. If the variances of two populations are equal, then we're going to use a pooled variances t-test, also I call the equivariance assumed t-test. If we see the two population variances are not equal, we are going to use a separate variances t-test, which also I call unequal variances assumed t-test. Okay, then for every t-test, based on your research question or anything else, that you have to decide whether you are going to use a directional test, which is a one-tailed test, or non-directional test, which is called two-tailed test. You have to decide for each of them. Okay, so to be noticed, one thing is that how do we know the variances are equal or not, which is in the second step, are the variances are equal or not. Okay, so it is a little bit complicated, and we use a test. The formula look like this. The thing is, in most of the stats class, when you're going to calculate it by your hand, as a fundamental practice to know t-test, something like that, we often giving the sentences like assume equal population variances or assume unequal population variances. If you take a look at those stats textbook or anything else practice textbook, you will see like when they give you the mean standard deviation of two samples, they ask you to run the t-test. It also give you information about like assuming equal population variances or assuming unequal population variances. This is like basically used for practice and for better understanding. Okay, but if you wanted to do this test to see if the equal variances are assumed or not, then you have to run a very complicated process and take a look at this sort of formulas as well. However, if we want to we would use like software, SPSS, data, even the Excel to run the t-test. We oftentimes we run this test on equivariances or equivariances test by using a test called F-test. I'm not going to talk about the F-test in this PowerPoint. I put this information in the stats by using Excel. You can check that video as well. Okay, but we do have like some ways to not assuming equal population variances or not. We can actually see if it is equal population or not. Okay, by using the F test in those software. So let's run the traditional 5 steps to this t-test hypothesis. Again, the 5 steps are the same. The basic process is the same, just like the chi-square test we just mentioned in the previous PowerPoints, right? Say the non and alternative hypothesis, identify the distribution. Of course, there will be t distribution. We are using the t-test. Get the degree of freedom and using the information in step 2 to find the critical value, the t critical value, then compute the t obtained value, and based on the critical value and obtained value, we're going to make a decision about whether we reject the noun or whether we accept the noun. Okay, let's take a look at some examples. The first example I'm going to show you is the independent sample t-test equal population variances or assuming equal population variances. Okay, so the research question is there a significant difference in the mean age at which juveniles were arrested for the offense that lead them to be transferred to adult court? As you know that not all the juveniles who are arrested for some kind of offense will go into adult court. Sometimes there is a cut point of age, and also it really depends on the crime they commit, or which you say the delinquency, the delinquency they commit. Okay, so we have 2 samples. As you can see, we already calculate the mean of the sample, standard deviation of the sample, and it give you the sample size. Similar to the sample 2, we have mean of the sample 2, standard deviation of the sample 2, and the sample size of sample 2. Okay, so you can see what we do here is that we looking at the dependent variable is the mean age, the age that they were arrested for the offense that lead them to be transferred to the adult. And the independent variable you will see here, it didn't show in the research question, but you can see in the table, independent sample here is about the race, right? We have Hispanic females or Hispanic female juveniles, and we have white female juveniles. Okay, so from here, sample 1 is the Hispanic female juveniles, and their mean age is 15.89 when they arrested and transferred to the adult court. Standard deviation 1.45. Sample size for the Hispanic females are 44. For the white female, you can see the mean age that transferred to the adult court is 16.57, standard deviation 1.11. The sample size is 31. Now, since you have this one, just simply compare the mean of the Hispanic female sample and the mean of the white female sample. You can see a little difference here is that it looks like the white female juveniles are kind of a little bit older when they be transferred to the adulthood compared to the Hispanic female, right? One is almost 16.5, another one is 15.9. You can see the absolute difference here, but is this difference a significant difference? Remember, in the stats, we are not looking at a difference like the absolute difference. Okay, we are looking at if this difference is statistically significant difference. Okay, so to see this difference, we have to use the t-test. And we set it at the alpha level at 0.05. And why this is two-tailed test? Because the question asks, is there a significant difference between the mean age, right? We don't ask like white female juveniles were older compared to Hispanic juveniles being transferred to the adulthood. We didn't say that. We say, is there a significant difference? So we use the two-tailed test. And here again, I said like most of the questions maybe ask you to calculate by hand in the textbook. It's going to give you population variances equal assumed or unequal population variances assumed. Here is equal population variances assumed. Okay, so what we here doing is two-tailed independent sample t-test equal population variances assumed. Based on this research question, the non-hypothesis will always be there is no difference between Hispanic juvenile and white juveniles. Okay, so mu1 equals to mu2. And the alternative hypothesis will be like, well, there is a difference between Hispanic female juveniles and juvenile offenders and white juvenile offenders, female juvenile offenders. So, but we don't know the direction, so we just say the mean age in two populations are different. Mu1 is unequal to mu2. Okay, two-tailed test. So in this t-test, of course, we use the t-distribution, and degree of freedom is calculated by this formula. Okay, different t-tests have different degree of freedom calculation formula. So for the independent sample t-test, the equal population variance is assumed that the degree of freedom is the sample 1 plus the sample 2, the sample size 1 plus the sample size 2 minus the 2. Okay, so in this example, the degree of freedom will be very simple. It's the sample size 1, 44, sample size 2, 31, minus 2, which is 73. Okay. Now the step 3 is going to find the critical value. Since we are going to use two-tailed test, so each of the room on the very left or on the right side will be what we call the rejection of non-hypothesis area, right? Just if you got confused a little bit, just go back to the videos and when we're talking about the chi-square. But the chi-square only has a positive side, so it's only going to the right side. But the t-test has two sides, and again we are using the two-tailed t-test, so it goes both ways, right? So we have information about to see the t-critical here. Okay, and here is supposed to have a negative number here and a positive number here. So we have the alpha level 0.05, two-tailed degree of freedom 73. Then you can pull out your t-table. Okay, first of all, alpha level 0.05, degree of freedom 73. We have find the two-tailed here, right? Two-tailed 0.05 of alpha level. Degree of freedom 73. There is no 73, but we can use 80 or 60. It doesn't matter which one. So they all pretty close. So in this example, let's use the 60. So you will see the t value is going to be the 2.000. So the t critical will be 2.000. But is this the correct one? It's not really it's half correct, right? Because this is a two-tailed test. That whatever the number we get from the t-table is always a positive number, but it is a two-tailed test, so there is a negative number. So the t-critical in this example actually has two values. One is a positive 2, another one is a negative 2. Okay, so the t-critical is negative 2 and positive 2. You can mark those two places. You can mark those two on the graph of the t value. of the t distribution. It's actually like a normal distribution. It doesn't matter. Okay, so you can see like we have the t critical positive here. If the anything t obtained based on the next step is larger than this one, which is in those rooms, rejection rooms, we are going to reject the null hypothesis. Or if it's on the negative side, it's less than the -2 on the left side. Okay, any kind of a t obtained in this side, then we are going to reject the null hypothesis as well. However, if the t obtained is somewhere in the middle, let's say like 0, 1, even like 1.5, these are in the middle, then we fail to reject the null hypothesis. That means we have to accept the null hypothesis. Okay. So when we're going to compute the obtained value, things are a little bit different, or each of the formulas are different. So in this example, we're going to compute the t obtained value for independent sample t-test. Equal variance is assumed. Equal population variance is assumed. The very first thing we are going to calculate the estimated standard error, which look like this one, and the formula of this one is this complicated. Okay, but the formula looks a little bit complicated, but it's not really that complicated as long as you put the right number inside of it. I'll show you in the next slides. Then you can see that the calculated t obtained is very simple. The mean of the sample 1 minus the mean of the sample 2 divided by this estimated standard error. That's it. Okay, it's quite simple. So the only difficult is that if you can put the right number into this formula and run and use your calculator correctly. Oh, that's the thing. Okay, so as you can see, we have the numbers here. Let's double check if you have all the numbers here. N1, we have S1, standard deviation of the sample 1. We have N2, we have that. S2, we have that. And yes, and X1 bar, we have that. X2 bar. Okay, we have everything, right? So just carefully replace those letters. Carefully replace those letters with the numbers here, with the numbers in the table, like 44 minus 1 multiplied by 1.47 square or something like that, and do the calculation. I usually do, if I do this one by hand or using a calculator, I do it like a very step by step, just in case I don't mess up anything. Okay, so whatever you have here is that you will have the what they call the standard error, estimated standard error as 0.21. Okay, you just have to carefully calculate this part to get 0.29, and the t obtained will be the very first mean minus the second mean, and also divided by the standard, what they call standard error, estimated standard error, something like that. You will get the t obtained as negative 2.34. Okay. So in the two-tilde test, if the obtained greater or less than t critical, then we are going to reject. If it's not, which means they are in the middle, we are going to accept the null, right? We mentioned this in the step 3 already. So what we have is that we have the t critical positive, t critical negative. And where is the t obtained in this way? We have the t obtained negative 2.34, which look like it's not in the positive side, so it's in the negative side, and which is here. Okay, so what did you see? The t obtained lies in the rejection of null hypothesis area. Yes? That's very easy to make your conclusion, right? So since the negative 2.34 is less than negative 2, t obtained less than t critical, therefore, it's in the rejection area. We are going to reject the null hypothesis. We are going to accept the alternative hypothesis, which is there is a significant difference in the mean age at which juveniles were arrested for the offense that led them to be transferred to the court. The dependent variable is the age, the mean age that being transferred to the adult court. The independent variable is actually the race. Okay, so to be noticed, one thing is that we use a two-tilde test. We cannot really draw a conclusion about the direction. Even you see the direction, the Hispanics' age of onset is earlier than the white of offense based on the mean. Okay, even you see this difference based on the mean, you can't really say it in your conclusion. Okay, why is that? Because your conclusion is really a two-tailed conclusion, and the two-tailed conclusion cannot safely say someone is bigger, someone is smaller. Okay, you just know there is a significant difference. Okay, what if you wanted to say the direction? Then you have to use one-tailed test to assume the direction. And what is the direction you probably assumed or you reasonably guess? Your reasonable guess is that the tail will be on the left, right? Because X1, the average of the Hispanic female juveniles average age is less than the X2 bar. You make a good guess based on the mean. You don't guess randomly. You guess like, I don't know, I guess white juveniles maybe older or white juveniles maybe younger when they're being transferred to the DACO. You can't make that guess. Okay, you cannot make that guess. Every time you make a guess, it must be based on some evidence. The evidence is average. Okay, so you can see the average of Hispanic female juvenile offenders are younger than the white juvenile offenders. So you make a good guess is that our one tail is going to be on the left side, the negative side. So once you change it to the one tail test, the thing changer here will be the T critical. Okay, because you're using the one tail. But the T obtained will still be the same. It doesn't really matter which tail you use. Okay, so if you use a one-tailed test alpha level 0.05 degree freedom over 73 where it is, you will see, okay, here alpha level 0.05, and make sure that you're looking at the one tail here, right? And degree freedom 72, and pick the 60 or whatever. Okay, so you will get a 1.671. And remember, we are assuming this is less than, smaller, younger. So it's a negative side. So this critical value will be a one tail, and it is on the negative side. So if you mark it later, you will see, I will show you in the few slides. Okay, but you know, this is the negative side. So the way we describe the hypothesis will be a little bit changed. The non-hypothesis is not going to be changed, but the alternative hypothesis will be mu1 less than mu2 because mu1 is younger than mu2. The average age of the first sample is less than the average age of the second sample. So what do we say is there is a significant difference, I mean the blah, 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 blah. Regarding age, Hispanic female juveniles were younger than white female juveniles when they were be arrested for the offenses that led them being transferred to the adult court. Now if we reject the null hypothesis, we can make a directional conclusion based on the alternative hypothesis. So can we run this one? Okay, so similar is that if you have a one-tailed test, a positive direction, you're looking at the positive side, right? If you have a one-tailed negative direction, you are looking at the negative side. Okay, so what do we have? We have a negative side, so we're looking at the left side. So anything that is less than this T critical will be the decision to reject the null hypothesis. Anything that is bigger, whether the T critical is negative 1.1 or negative 0.1 or even 0.5 or even 10, whatever. So we are going to accept the null hypothesis. Okay, anything that is less than negative 1.671 is going to be our rejection decision maker. Okay, so the T obtained is not going to change. It will be the negative 2.34, which is less than this T critical. So what is our conclusion? Very simple, right? Our conclusion is going to reject the null hypothesis, accept the alternative hypothesis. And again, since here we make the alternative hypothesis a directional guess, so we can make a safe conclusion that whichever I highlighted here, there is not only there is a significant difference, but also the difference is Hispanic female juveniles were younger than white female juveniles when they being arrested for the offense that led them being transferred to the adult court. Okay, it's more safe to say that. Then we go into move on to the independent sample t-test. Unequal population variance is assumed. Every logic, when we're going to make the conclusion, we compare the obtained value to the critical value, and we make a conclusion based on the one direction or two directions or non-direction, which means two directions. Every logic is the same. The difference might be in like the degree of freedom or how to calculate the obtained value. That's it. Okay, but every logic is the same. So in this example, the research question is there a significant difference in the mean time at which juvenile's case to be disposed of regarding different types of attorney the juvenile has? So private attorney, expensive. Public defender, sort of cheap and free, right? Again, we have two samples. The private attorneys group has a average mean time or the average time or the mean time at 7.93. The public defender has 6.36. Standard deviation to sample size 1, sample size 2, cool. And we use alpha level 0.01. And let's say, well, based on this question, is there a difference? It should be like a non-directional test, which is a two-tilt test. But you can see based on the average, we can make a good guess is that private attorney maybe see the time is longer than or longer. Yes, it's longer than the public defender's time, right? Sort of like bigger. So we can use the one-tilt test as long as you can make a good suggestion. Okay. The difference here is that we assume the population variances are unequal. Okay. So research question would be like that. Since we use the directional test and we have a good reason to believe that the mu1, which coming from the x1 bar, is bigger than the mu2, which is coming from the x2 bar, we have good reason to believe that the population 1, the average time in the population 1 is larger than the average time in the population 2, average time in the population 2. Okay, but the null hypothesis will still be the same, like mu1 equals to mu2. There is no significant differences. The alternative will be there is a significant difference. What is the difference? Since it is large, the difference will be juveniles who had a private attorney would have longer time to disposition than the juveniles who had public defender. That's the direction, right? So again, the distribution, we are going to use a t distribution, which we call the t-test. However, the degree of freedom look like, holy, what the hell is this, right? Well, the degree of freedom in the unequal variance assumed independent sample t-test, it's just look like that. And remember, when you calculate everything in the middle, make sure you minus 2 as well. Okay. However, if you take a look at that things, everything number you have is right in the table, like standard deviation 1, standard deviation 2, sample size 1, sample size 2, right? Everything else is the same. So once you put every number and you replace them, you put every number in, you replace those letters, be careful. Okay, when you calculate this middle part, so I use like a calculator to calculate at least 3 times to make sure this number is correct. And I calculate like step by step. Don't put everything into one and click equal and you mess up something. Okay, click not calculate each of the thing by process slow, and then you will get don't forget to like minus 2 here. Then you will have the degree of freedom around 63. Okay, now we have the thing we need to find the critical value. Again, in this example, we assume there is a direction, and because the direction x1 bar is larger than the x bar, so we use a positive direction, right? Positive direction is somehow here. So any number the t obtained is here, then we are going to reject the noun. And in t obtained value is in the middle or somewhere left, we are going to accept the noun. Okay, so what is a critical value? Again, we're looking for the alpha level 0.01, degree of freedom 63. Remember, we're using a one tail. Don't forget about double check the one tail here, right? Degree of freedom of 63. We pick the 60 as well. We will have the t critical at 2.390. And since this is a one-tailed test, we have to consider, is this a number, is this a positive number or a negative number? And we are in the right side, so this is the positive number. So we use a t critical as positive 2.390 because it is a positive one-tailed t-test, right? Mark it here, okay? T critical is positive 2.390. And once more, again, if you get the t obtained here, maybe t obtained is 5, you are going to reject the noun. If you get a t obtained like 1 or maybe negative 1, then it's in the non-rejection area, then you are going to accept the noun hypothesis. Okay, so actually, you see, if the degree of freedom is a little bit complicated to calculate in this example, then the obtained value is really easy. Still, you have to calculate the estimated standard error first. Now, for the unequal population variances, the estimated standard error look like this. Okay, quite simple. You also already have all the numbers regarding the S1, S2, N1, and N2, right? Then you calculate the t obtained similar to the equal population variances. The formula is similar to the one. The difference is that the different formula used to calculate the standard error in the bottom here. Okay, carefully replace every number within this formula. Replace every letter or insert every numbers into this formula. Do this slowly with your calculate. You got the standard error as 0.81 and use the mean 1 minus mean 2 divided by the standard error, you got positive 1.94. Okay, so positive 1.94, we mark this t critical is here. Rejection area is here. Where is the positive 1.94? It's somewhere less than t critical. And since it's less than, it's in this area, which is the non-rejection area. So what is your conclusion? Quite simple, right? Again, this is just a repeat. How do we make a decision based on the one-tailed test? Okay, I'm just going to skip this one. So positive 1.94 is less than positive 2.39. So the t obtained is less than the t critical. At this moment, we can only accept the null hypothesis. Okay, because it's in the non-rejection area. We have to accept it. So we have to accept the null hypothesis. The conclusion is there is no significant difference in the meantime at which the juvenile's case to be disposed for regarding the different types of attorney the juvenile has. Okay. Now the second thing is, what if we use a two-tailed test? We use a one-tailed test in this example, right? So what if we use a two-tailed test? Everything will be the same. The difference is what? The t critical, right? The t critical will be a little bit different, and also t critical will also have a positive number and a negative number here, right? So again, alpha level 0.01, degree of freedom 63, but this time we looking at a two-tail. So mark here, two-tail 0.01, degree of 60, so we get 2.66. And also this time we do the what? Two-tailed test. So therefore the t critical will have a positive number, a positive 2.66, and a negative number, a negative 2.66. Okay, now we mark this here. Okay, we mark the positive and the negative. If it's larger than the positive number, we're going to reject. If it's less than the negative number, we're going to reject. If it's in the middle, we are not going to reject. What do we have now? Still, we have the same t obtained 1.96, which is a positive, but it's in the middle, which is in non-rejection area. So even from a two-tailed test, we can still safely say in that there is no significant differences in the mean time at which juvenile's case to be disposed regarding the different types of attorney the juvenile has. Okay, because we accept the null hypothesis. And again, here, since we use the 0.1, 0.01, right? Alpha level 0.01, which means our confidence interval is confidence is what? 99% confident. Okay, so when we make these suggestions, statistically speaking, if we make 100 times decision, 99 times we are going to make a decision. There is no difference, and only one time we're going to make a mistake that there is a difference, but we didn't find it. And again, I want you to pay attention is that if you go back to the video a little bit, you will see the mean 1 and the mean 2 look like really different. Okay, look like really different. But again, we say in the stats, we are not looking at if there is a difference. We are looking at if there is a significant difference. And based on our calculation and t-test and the probability testing, we can just say I have 99% chance to be correct, or I have 99% confidence that there is a difference, but this difference is not significant. Okay, so the very last type of the t-test we are going to talk about is the dependent sample t-test. Again, every logic, every step is the same, as it's just some ways to calculate the degree of freedom, and some formulas in calculate the t obtained will be a little bit different, but the logic is always the same. Okay, for the dependent sample t-test, those means like two samples are somehow related, like pre-post, matched pairs, and we're going to use this example. Is there a statistically significant difference between states with high or low arrest in terms of officer assault? Okay, so we match the state 1 or state A and B together, state C and E together, state F and H together, state E and G together, state I and J together. Okay, and to look at their officers per 1,000 officers, low arrest rate and high arrest rate. Okay, so what we are looking at is some of the state has a low arrest rate, some of the states has a high arrest rate, and what about the impact on the officer assaults? Maybe the state who officer arrests more people may have lower officer assault rate, or maybe they have higher. We don't really know, right? Now we match the state A and B, C and E, F and H based on something, maybe the population, maybe the economic status, but this is just example. Okay, we match them. So what do we have here is like this one, the group 1 or pair 1, pair 2, 3, 4, 5, and the higher arrest rate like here. Okay, again, the research question is this, and the non-hypothesis will be, well, there is no difference between the states with high or low arrest rate in terms of officer assault. There's no difference. Always mu1 equals to mu2 in the non-hypothesis in a t-test, whatever the t-test it is. Okay, the alternative hypothesis here, we say is there a significant difference? We say there is a difference, but I don't really know, because I can't really tell like what the difference is. So I just use the unequal to mu1 is unequal to mu2, and we don't know the direction. Okay, so second step is going to identify the distribution. Of course, again, still t distribution. Compute the degree of freedom. Oh, it's very simple, right? The degree of freedom in match group t-test or dependent sample t-test is just the number of the pairs minus 1. Remember, this is the number of the groups, number of the pairs. So what do we have? We have 5, right? So 5 minus 1 equals to 4. Now find the critical value. You guys are kind of familiar after like 40 minutes. You are very familiar with how to do this one and how to interpret the two-tail, one-tail, and how to find the critical value. So again, this is two-tail the test alpha level 0.1, two-tail the degree of freedom 4, and it's a two-tail. We have positive side here, we have negative side here. So alpha level 0.05, degree of freedom 4, 0.05, and remember this is two-tail. Okay, two-tail here. Degree of freedom 4, what do we have? 2.776. That's the absolute number of the t-critical. And since we have a two-tailed test, we go either way, a positive side or a negative side. So we have a positive 2.776. We also have a negative 2.776. Mark this on the graph. This is a thing I like because it's more clear and it helps you to make a decision in the step 5. So again, if the number t obtained is like a 5, 6, or maybe even 100 here, then we are going to reject the null hypothesis. If it's very small, like a -3, even -100, then we are going to reject the null, right? But if the t is in the middle, like 1, +1, no -1, it's in the middle, then we are going to accept the null hypothesis. Okay. Step 4 is going to compute the obtained value. It's not hard. It's very kind of simple. So you have to, first of all, you calculate the standard deviation of the difference between the means, formulas like this one. Okay. Then the XD means the difference scores x1 minus x2, the group 1, or yeah, just like the population 1 minus the population 2 for each of groups. And the XD bar is the mean of the difference scores. Okay, so you calculate the difference scores, and also you need to calculate the mean of the difference scores. And then you calculate the standard error, familiar? Right? You always calculate the standard error like as the bottom of the formula of t obtained, right? So it's just like a standard deviation of the the difference scores here, right? And divided by the square root of the number of the pairs. And also you can see this top is no longer x1 bar minus x2. It is the mean of the difference scores. Now, the calculation formula seems complicated, but I give you, again, if you want to calculate, practice by hand and get to know why we do that. It's a good way to know why we do that by calculating using your hand. Okay, so you can again use this worksheet. Okay, you put the general information here and general information here, what you get here. So then you put every number into it. So in theory, this let's make it like a low arrest rate x1, high arrest rate x2. So this column just the different scores, x1 minus x2. Okay, x1 minus x2 for each of them. And this is the then you have this different score, and you have to calculate the mean of the different score. How do you calculate? Yeah, you add all the things together divided by what? 5, because there are 5 groups. You got the average difference scores. And you use the difference scores minus average difference score. So for this cell, it's like a 0.26 minus 0.34. For this cell, it's 0.64 minus 0.34. Okay, and then you square this thing. Okay, you square every number here, and what's the sigma mean? You add those numbers together. Okay, that's what you have. Then take a look at the formula here is that you have to estimate the standard deviation of the differences. Okay, so what you have here is you will get 0.268. You already have all the numbers, right? This number is right here. And the pairs is 5 minus 1. You already have everything. So you get the standard deviation of the difference score is 0.268. And then you will use this SD like here, okay, to calculate your what they call estimate standard error right here, which is you gotta use this number divided by the square root of 5, which you have 0.12. Then finally you got the t obtained, which the top is the average difference score, which is 0.34 like here, right? And the bottom is the standard error, which we just calculated 0.12. That's here. Okay, so what you have is that finally, okay, it's a t obtained as a positive 2.83. Okay, let's make a decision. Now this slide is just continue showing you the words, the how we make a decision based on those sentences, but it's so complicated. We just going to picture it, so it's more easy to picture it to make a decision, right? So you have two, okay, one is on the positive side, one is on the negative side. What do you have? Okay, it's a little bit higher, it's a slightly higher, but it's still higher, right? So we have the T obtained positive 2.83, which is higher than this T critical positive 2.76776, which makes this T obtained in the rejection area. Therefore, our conclusion is going to reject the noun, accept the alternative, right? Here we are in the rejection area. Okay, so the conclusion is there is a statistically significant difference between the states with higher or lower arrest rates. Again, however, we're using a two-tailed test. We cannot make a conclusion on which one has a higher or more officer assault. State with low arrest rate or state with high arrest rate. We cannot do that because we're making a two-tailed test. Our alternative hypothesis is a two-tailed hypothesis. It's a non-directional test. We cannot make a conclusion on the direction, right? So what if we want to make a the conclusion on the direction? So let's say, well, we look at the low arrest rate and high arrest rate. First, look like this group has a higher than this one, higher than this one, higher than this one, higher than this one. Oh, it's a smaller. Okay, the first four is higher, bigger. The last one is smaller. So what's a good way we guess here? Smaller, bigger, or smaller? Actually, it's a bigger, right? Because when we take a look at the data, it looks like four groups are higher in lower arrest rate than high arrest rate. Only one group is less. So we make a good guess about bigger. So everything else is the same, but the alternative hypothesis is different. There is a statistically significant difference between blah 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 blah. States with low arrest rate have more officer assaults than the state with high arrest rate. This is a good guess based on the previously. This one, right? We make a good guess. So what the changes here is that we're making a large, bigger, more guess. So it's a positive side is going to be on the right side. And also we use a one tail, so the critical will be a little bit different, right? Alpha level 0.05, degree freedom 4. You already know this very much. And the T critical will be 2.1. Oh, remember, this is going to be the one-tailed direction, one-tailed here. Okay, so the T critical will be 2.132. And since it's on the right side, it is going to be the positive 2.132. And then make a conclusion. Okay, so again, we now have our change the T critical as 0.2 as 2.132, right? So we have the obtained is not going to change. We calculated this whole thing. It is the positive 2.83, although it is slightly bigger, but it's still bigger. Okay, cool. So if it's bigger, it goes to this right areas in the rejection of non-hypothesis area. So what is our conclusion? So our conclusion is simple. We are going to reject the non-hypothesis and accept the alternative hypothesis. And since we are going to use, we were using one directional test, okay? So there is a significant difference. What's the difference? State with a low arrest rate have more officer assaults than the state with high arrest rate, okay? You have, as you can see, all the hypothesis test in this one t-test, whether you have the independent sample t-test, equal variances assumed, or independent sample t-test, unequal variances assumed, or dependent sample t-test, the logic is always the same, right? The logic is always the same. That's it for the t-test.